Could an object be in two places at the same time? This question may sound like a riddle or a trick, but it's actually a central concept that delves deep into the fascinating world of quantum physics. It's a field that challenges the very core of our understanding of reality and the way we perceive the world around us. Picture this. You're in your room, and suddenly you're also in the kitchen. Sounds like a scene from a science fiction movie, doesn't it? Well, in the bizarre realm of quantum physics, this isn't merely a fantasy. This phenomenon, known as superposition, suggests that particles can exist in multiple states at once until they are observed or measured. But what does this mean? In essence, superposition implies that until you open that door to check, you could very well be both in your room and the kitchen simultaneously. It's mind-boggling, isn't it? Now you might be wondering, is this all just theoretical? Not at all. Quantum physics is much more than a theoretical concept. It's a tangible, practical field that has far-reaching implications in our daily lives. Think about the device you're using right now to listen to this. Whether it's a smartphone, a laptop, or a tablet, it wouldn't exist without our understanding of quantum mechanics. The technology behind these devices, the semiconductors, relies heavily on quantum principles. And it doesn't stop there. The field of quantum mechanics is continually evolving, with researchers around the globe making groundbreaking discoveries that have the potential to revolutionize our world. From quantum computing, which could exponentially increase our processing power, to quantum teleportation, which, despite its name, isn't about beaming you up, but rather about transferring information instantaneously across vast distances. So, buckle up as we dive into the quantum realm where the impossible becomes possible. In this world, your intuition might be challenged, your perception of reality may be shaken, but one thing is for sure, your mind will be blown. Can you know both the speed and position of a particle at the same time? If your instinct is to answer yes, then buckle up. You're about to dive into one of the most perplexing conundrums of quantum physics. Heisenberg's uncertainty principle. Here's a gist of it. The uncertainty principle, proposed by Werner Heisenberg in the early 20th century, states that it is fundamentally impossible to measure both the position and velocity of a particle with absolute certainty. Yes, you heard it right. It's not about the limits of our technology or a lack of precision in our measuring tools. It's about the fundamental laws of nature. Let's break it down a bit. Imagine trying to spot a tiny particle under a microscope. To see it, you have to shine light on it. But here's the catch. The very act of observing affects the particle. The light photons bounce off the particle, changing its speed and direction. The more accurately you try to measure one property, the less accurately you can know the other. This mind-bending principle isn't just an academic thought experiment. It's a cornerstone of the quantum world, where particles can be in two places at once, pop in and out of existence, and even affect each other instantaneously over vast distances. Let's take a moment to appreciate the sheer audacity of the universe. In our everyday lives, we're used to knowing where things are and how fast they're going. We can track a car moving down the street, a ball flying through the air, or a person walking in a park. But in the quantum realm, these everyday rules no longer apply. Here's the thing, the uncertainty principle isn't about creating confusion. It's about embracing the inherent unpredictability of the quantum world. It's about accepting that at the core of existence, the universe is far stranger than we ever could have imagined. The uncertainty principle reminds us that the quantum world is full of surprises. But don't worry, there's plenty more quantum weirdness to explore. So stay tuned as we delve deeper into this fascinating realm. Can two particles be connected no matter how far apart they are? Well, in the quantum world, the answer is a resounding yes. Welcome to the realm of quantum entanglement, a realm so strange and counterintuitive, it'll make your head spin. Let's start by understanding what quantum entanglement is. It's a phenomenon where two particles become inextricably linked. And no matter how many light years separate them, the state of one particle will instantly influence the state of the other. This isn't just theoretical, it's been experimentally verified. Now, let's take a step back and imagine two particles. They come into contact, interact, and then fly off in different directions. They could be light years apart, but they remain connected. Change the spin of one, and the other changes too, instantly. This is not because they are sending signals faster than light. Instead, they are entangled. Their states are dependent on each other regardless of the distance between them. But how does this happen? Well, the answer lies in the heart of quantum mechanics itself. When particles interact, they can become entangled due to the conservation laws of physics. These laws ensure that certain properties, like momentum or spin, remain constant before and after the interaction. This is what binds the particles together, creating this so-called spooky action at a distance. The implications of quantum entanglement are far-reaching. It challenges our understanding of the universe and the nature of reality itself. It tells us that on the quantum level, the universe is not a set of isolated objects, but a web of connections, and it doesn't stop there. Quantum entanglement is a cornerstone of emerging technologies like quantum computing, which promises to revolutionize information processing. It also has potential applications in secure communication, quantum teleportation, and more. Quantum entanglement shows us that at the quantum level, the universe is deeply interconnected. It seems as if the universe is whispering to us, telling us that everything is not as it seems and that we have much more to learn about the nature of reality. What if computers could solve problems in mere seconds that would take traditional computers thousands of years? Let's dive into the fascinating world of quantum computing, a concept that has the potential to redefine the boundaries of technology. Quantum computing, as the name suggests, is a type of computation that harnesses the peculiarities of quantum mechanics to process information. Unlike traditional computing that uses binary bits represented as zeros and ones, quantum computing uses quantum bits, or qubits. These qubits can exist in a state of 0, 1, or both at the same time, thanks to a quantum phenomenon known as superposition. This means that a quantum computer can process a vast number of possibilities all at once, performing complex calculations at unprecedented speeds. But it doesn't stop there. Quantum computers also leverage another quantum marvel, entanglement. When qubits become entangled, the state of one qubit is directly related to the state of another, no matter how far apart they are. This characteristic allows quantum computers to perform multiple calculations simultaneously, exponentially increasing their computational power. Now imagine the potential impact of such technology. In the field of medicine, quantum computing could help design new drugs or analyze complex DNA sequences in seconds. In cryptography, it could crack the most sophisticated encryption codes, redefining the concept of online security. And in artificial intelligence, quantum computing could enable machines to learn and make decisions faster than ever before, bringing us closer to the dream of true artificial intelligence. However, it's important to note that quantum computing is still in its infancy. There are significant technical challenges to overcome before we can fully harness its potential. But the progress we've made so far is promising, and the future of quantum computing is undoubtedly exciting. Quantum computing promises to revolutionize our technological capabilities. As we continue to explore this frontier, we may soon witness a world where problems that once seemed insurmountable are solved in the blink of an eye, thanks to the power of quantum computing. So, why does quantum physics matter to you, you might ask? Well, the answer is simple, yet complex, much like the subject itself. With our journey through quantum physics, we've peered into a world that's both peculiar and profound. We've seen how the uncertainty principle challenges our classical understanding of reality, where particles can exist in multiple states simultaneously until observed. It's a realm where certainty is replaced by probabilities, a shift that has fundamentally redefined our understanding of the universe. Then we delved into the eerie phenomenon of quantum entanglement, which Einstein famously referred to as spooky action at a distance. It's a concept that defies our conventional understanding of space and time, where entangled particles, no matter how far apart, seem to communicate instantaneously. This has opened up tantalizing possibilities for unbreakable encryption and superfast communication. And who can forget the mind-boggling potential of quantum computing? This technology, still in its infancy, promises to revolutionize the future, capable of processing vast amounts of data and solving complex problems far beyond the reach of our current computers. But the quantum revolution doesn't stop there. Our understanding of quantum physics is ever evolving, with every new discovery unlocking more questions than answers. It's a field where the impossible becomes possible, where we continually push the boundaries of what we know and understand. It's not just about the scientific breakthroughs, though. Quantum physics is a testament to human curiosity and our relentless pursuit of knowledge. It encourages us to keep questioning, to keep exploring, and to never stop marveling at the wonders of the universe. So, as we stand on the brink of a quantum revolution, remember that you too are a part of this journey. You too can explore the quantum world, question the nature of reality, and contribute to the knowledge of the universe. As we continue to unravel the mysteries of the quantum world, who knows what incredible discoveries await us?